So today we're talking about neutrophils and their effects on the glycocalyx. Your neutrophils are your white blood cells. They're your innate immune system, and they have a very important role when fighting pathogens. If you have a co-infection or you've ever heard of immunosuppression, then you have a slow innate immune system. Now, what does that mean specifically? It means that your immune system gets stuck easily, it's sticky, like globby, and doesn't move around fluidly. And this whole system relies on what's called the glycocalyx. The glycocalyx is this hair-like structure that's on your endothelial cells, like your blood vessels, on the outside of your neutrophils and your mast cells and other immune cells. It's on the outside of bacteria. It's kind of the way that we have easy water and able to move around fluidly through all your extracellular matrix. That way your cells don't stick. But when your innate immune system needs to eat something up, it creates these neutrophils here. These neutrophils create neutrophil extracellular traps that release mediators that chop up this glycocalyx. They nip it there, etc. We'll talk about that in a second. And that causes these to shed freely and float around the blood, but at the same time, they are able to stick to their pathogen. Imagine a bacteria here. Now it can stick to the pathogen because they eat up the gel-like layer around the pathogen. See, your immune system needs to be able to trap parasites and bacteria and viruses so they don't freely get around the blood. But your immune system also needs to be able to get into that damaged tissue. So it creates these scissors and it chops through everything. It chops through your collagen, through your extracellular matrix. It chops through the cell membrane. On bacteria, it's fighting. It upregulates proteins that open up tight junctions so your cells kind of split open, and then your immune system goes from the blood into that tissue. It just opens up that blood vessel. So cool. But this is where things get tricky, is if that stays open or too many areas get too open. Most people only talk about this in regards to the gut, like dysbiosis opens up tight junctions in your gut, which is called leaky gut, intestinal permeability. But that happens in your vascular system. That happens with your kidneys and kidney disease. That happens with your liver, non-alcoholic fatty liver disease, or NASH. It also happens with vascular dementia in your brain. But when you don't rebuild that matrix around those cells, those immune cells, and they don't die out properly, then your innate immune system can get stuck to blood vessels, to the cell wall. So let me show you over here. These here are immune cell getting stuck to endothelial cell. Like even platelets can get stuck here. That makes you very sticky and clotty, and your blood doesn't flow well. So you stand up and you feel kind of fainted because your microcirculation doesn't work well. When you had a really stressful challenge, something that broke the camel's back, did it cause you to never be the same again? If you had a virus and it messed you up, you're probably post-septic. What does that mean? It means that bacterial fragments were able to get into your blood and stop your innate immune system from working. So you become immunosuppressed. And because your innate immune system is suppressed, you can get co-infections very easily. Or you can build up toxins really easily because you've depleted all the cofactors with cleaning up from the virus. I had EBV and I was post-septic, but I didn't know about it until years later because I had to learn the long way, the long EBV way. You see, what happens in sepsis is your blood clots everywhere and bacterial fragments get into all the wrong tissues. On top of fighting a virus, the bacteria there cause your innate immune system, the things that eat up the virus, to become tolerant and exhausted. And so your adaptive immune system has to kick in. Your adaptive immune system comes in with cytokine storms. So they create a lot of chemicals to try to attack pathogen. That's really damaging to you as well. And on a microscopic level, that's called autoimmune disease, when the immune system is attacking yourself or giving you collateral damage, more like it. See, anytime a PAMP or DAMP is activated on a toll-like receptor, that will cause a cytokine release. And you know what's wild about stress? Stress releases norepinephrine. And norepinephrine does two different things when you are sick. It makes your blood clot by activating platelets, and it stops you from draining lymph well because it blocks aquaporin. So working on stress and your norepinephrine levels is really important, so you're not looping back into clotting yourself. None of this is medical advice, of course. Always talk to your doctor about doing something, but I have a secret for you. I have a guide called Junction Dysfunction that shows you how all this works in a self-reorganizing complexification system called Junction Dysfunction. And you can find it on my biohack, and you can find it in my bio, and you can find it in the description below, and you can find it in the link below, and you can find it in the link in my bio, and you can download it here. Okay, that's all the ones I can think of. Thanks for listening, and stay beautiful. Well, I'll catch you in the next one.